Welcome to our second lesson in our chemistry lecture series. In this topic, we'll be looking at pure substances, mixtures, solutions, suspensions, and colloids. The objectives that will be covered in this topic will include distinguishing between pure substances and mixtures, distinguishing among solutions, suspensions, and colloids, and finally, identifying different types of solution. Let us begin. Before we distinguish between pure substances and mixtures, there are some very important terms that we must try to understand. So we will start by looking at an atom, element, and compounds, and so on. Let us begin by looking at an atom. Now, we say that an atom is the smallest particle of an element which can exist. And of course, we know that the atom, it makes up the element. So an element is a substance which cannot be split up into two or more simpler substances by chemical means. Therefore, an element is made up of entirely one type of atom. So we're saying here that if I have the element sodium, then sodium element is made up of smaller particles called sodium atom. Now, all substances are elements or they are made up of elements. Each element is represented by a symbol. This may be one letter, which is a capital letter, or more than one letters, where the second letter is a lowercase letter. For example, let us look at the element carbon. Here we see where carbon is one element, and it is a capital letter. If in the case of sodium, where we have N being capital and A being common, is dealing with one element, sodium. When we have an element that's made up of two letters, the first one is capital and the second one is common. So, an atom or atoms make up elements and elements make up compounds. So we can see here that a compound is a substance which consists of two or more elements chemically combined together. Example, calcium oxide. Calcium element is made up of calcium atoms, and the element oxygen is made up of oxygen atoms. These two elements are chemically combined to form the compound calcium oxide. Now, calcium oxide is an ionic compound, and ionic compound are solids. We will discuss ionic bonding later in further topics, so don't worry too much about the term ionic compound if you don't understand already. Molecules form when two or more atoms form chemical bonds, and when I say atoms here, I'm talking about atoms that makes up the element. So molecules form when two or more elements or atoms that make up that element form chemical bonds. And once you are a molecule, you are covalently bonded. So ionic and covalent bonds are bonds that we will discuss at a later date. Just remember that if you are an ionic compound, you are a solid. If you are a covalent compound, you are a gas or liquid, and you form molecules. Here we have some examples. Water would be a liquid, which is a molecule. N2, which is nitrogen, is also a molecule, and it is covalently bonded. Oxygen is also covalently bonded, and glucose. So these are all examples of molecules which are covalently bonded, and they can be either liquids or gases. Now, I really want you to understand that if you are a molecule, you also form a compound. So not only ionic solids form compounds, but molecules also form compounds. But molecules are special types or forms of compounds. Now, molecules are made up of two or more elements called compounds. So we see here that compounds can be ionic in the case of solids, or covalent in the case of gases, or liquids in the case of water. Molecules are only covalently bonded, as in the case of liquids or gases, while compounds can be both covalently or ionically bonded in the case of gases, liquids, or solids. So that is how we distinguish between a molecule and a compound, where we're saying that a molecule is covalently bonded, where the compound can be both covalently as well as ionically bonded. Now that we understand that atoms makes up the element, and that elements, when they are chemically combined, makes up the compound, we can move on now to look at the differences between a pure substance and a mixture. We can say that matter exists as pure substances or impure substances. If the substance is impure, it is a mixture. If the substance is pure, it can either be an element or elements or a compound. Simply put, a pure substance is a substance that contains only one component. It has a fixed composition and has unique properties. Remember, it contains only one type of element or compound. That is, it is homogeneous, continuous throughout. Remember, compounds are made up of elements that have been chemically combined in the case where you saw calcium oxide, which makes them pure substances. Now, a mixture consists of two or more elements or compounds which have not been chemically combined. That is, it contains at least two physically combined compounds. Now, it can be homogeneous or heterogeneous. The term homogeneous or heterogeneous simply means, in the case of homogeneous, it means that the composition is the same throughout. Whereas in heterogeneous substances, the composition is different. So you can tell the difference between one substance and the other. Here are some common examples of mixtures. Air, which is made up of different gases, is a mixture. Seawater is also a mixture because it is made up of water and salt. In this case, the salt is sodium chloride. Of course, there are many other types of mixtures, including salt and sand, water and ethanol, or anything that you can combine physically. That would be considered a mixture. So, how can you tell if a substance is pure? Well, pure substances usually have definite sharp melting points and boiling points. But if any impurity is added to that substance, then the melting point and the boiling point will change. Let's look at in the case of water. Water that is pure will boil at 100 degrees Celsius and it will freeze at 0 degrees Celsius. That is, it has a fixed boiling point and a fixed melting point. Now, if salt should be added to this water, then it will not boil at 100 degrees but at a higher temperature. If you freeze it, it should not freeze at 0 degrees Celsius but at a lower temperature. We're saying then that the presence of impurities, it will increase the boiling point and lowers the melting point of ice. So generally, an impurity increases the boiling point of a substance or liquid and decreases the melting points of a solid. So just remember, if a substance is pure, it will boil at its boiling point or freeze or melt at its melting point. If it is impure, the melting point will be lowered and the boiling point will be increased. Now, here are the main differences between mixtures and compounds. In a mixture, we look at the composition of the substance, that it can be mixed in any amount. So the composition is not fixed. Whereas in a compound, the elements must be combined in fixed amounts. In terms of separations, a mixture can be separated easily by physical means. Physical means meaning filtration or evaporation. Whereas in terms of compounds, the elements cannot be separated from the compound by physical means. In terms of heat change, there are no heat energy involved in terms of mixtures. whereas in compounds, heat must be either absorbed or released during the formation of that compound. The substances making up the mixture retain their own properties, that is, color and density. All we're saying here is that they are simply mixed together, but they retain their property, their physical properties. Whereas in a compound, the properties are different from those of the element. So sodium, its properties are different from sodium chloride. Chlorine, its properties are different from sodium chloride. So we're saying that when the elements combine together, they are different in terms of their properties. And the substances in mixtures can usually be distinguished, while in compounds it is very difficult to distinguish between the different elements in that compound. Let us distinguish now between a solution, a suspension, and a colloid. And these are all mixtures. Now, the main properties that we will use to distinguish between the three will include the particle size, the passage of light, and sedimentation. Particle size means, are the particles large, medium, or very small? Will light be able to pass through the mixture, or will it be scattered? Will the particles in the mixture settle, or will they remain suspended throughout the solution or the mixture? So now let's look at a solution. Now a solution is a uniform mixture of two or more substances. In terms of particle size, in a solution, the particles are very small. So small that you cannot see them if they are completely dissolved. Now, because the particles are small, light will be able to pass right through the mixture without being scattered, and there are no particles that are large enough to settle out on standing. So in a solution, the particles are very small. Light will pass right through, and there are no particles large enough to settle out. Just remember that in a solution, the particle size, they are small. They are small enough that they will pass through a filter paper. Therefore, they cannot be separated by filtration. An example of a suspension would include muddy water or sand in water. Now, the particles in a suspension, they are large. Now, that's in terms of their particle size. Being large, they will scatter light. And if they are allowed to stand, they will settle out. Now, remember we said that the particles are large. Now, if they are large, it means that they will not be able to pass through a filter paper and thus can be separated by filtration. So, the particles in a suspension, the particles are large, and if they are large, eventually, if they are allowed to stand, they will settle and sink to the bottom of the container. Light will come in and it will be scattered by the large particles. So light will not be able to pass through. And the particles are so large that they cannot pass through the small holes in the filter paper. In a colloid, the particles are larger than the particles in a true solution, but the particles are smaller than the particles in a suspension. Now, if the particles in the colloid, if they are larger than the particles in a solution, then when light is passed through the colloidal mixture, it will scatter light. Notice here that the particles passing through the solution, you cannot tell the path the light takes going through because there are no particles present or large enough to scatter the light. So you can't see the path. In a colloidal solution, the particles are suspended in the mixture and it scatters the light beams as it passes through. So you can actually see the path the light takes going through the colloidal mixture. Note that the particles remain suspended because they are smaller than the particles in a suspension. therefore will not settle out on standing. Just remember that the colloidal particles scatter light, and that we call the Tyndale effect. In a suspension, light will be scattered because the particles are very large. In a solution, light will not be scattered. In a colloid, light will be scattered. So we use the Tyndale effect to distinguish between a true solution and a colloidal solution or mixture. Here are some other types of solutions. Now, the moment you hear solution, then you're thinking about a mixture. Now, in a solution, we would say that one of the particles, normally the solid particle, is the solute. And in the case of liquid, the liquid would be the solvent. Not all the time you have a solid being a solute or a liquid being the solvent. You have other types which you can see here. Now, in terms of a gaseous solution, the solid will be the solute while the gas will be the solvent. The liquid can be a solute and the gas the solvent, or a gas the solute and a gas the solvent. And here we have some examples. For example, it says sublimation of solid in gas. For example, the camphor ball in N2 gas, water vapor in air or mist. And these are mixtures of gases in air. Liquid solutions include a solid being the solute and a liquid the solvent. Or a liquid can be the solute and another liquid the solvent, or a gas the solute and a liquid the solvent. And we have examples here. Salt in water, sucrose in water, alcohol in water, and mixtures of miscible liquids. Also, aerated drinks. For example, carbon dioxide in water. So carbon dioxide would be the solute and water the solvent. Solid solutions will include a solid, that would be the solute, and another solid, that would be the solvent. A liquid will be the solute and the solid the solvent. Or a gas the solute and the solid the solvent. And examples will include alloys. And we say that alloys are mixtures of two or more metals. Mercury in zinc or mercury in gold. Or adsorption of gases on metals. Solutions of hydrogen in palladium. Now these you can check out in your textbooks. And you can see other examples of different types of solutions, where we have gaseous solutions, liquid solutions, and solid solutions. This concludes our lesson on pure substances and mixtures. In our other topic, we will discuss how do we separate mixtures based on different separation techniques. See you then.